So welcome back. Again, we're going to work with systems of equations, and we're going to solve this system of equations. Again, we're going to use what we call the elimination method. And in the elimination method, we have to put the equations in what we call standard form. We have to have ax plus by equals c. We prefer the a, b, and c to not be fractions. We also prefer the coefficient of x to be positive. So if we look at these problems right now, let's start with the first one. It's not in standard form, so I'm going to rewrite that. So I have a negative 24 minus 8x equals 12y. So I need the x and y on one side, I need the constant on the other side. So what I'm going to do is, I need the x and y on the same side. I'm going to go ahead and bring this 12y over here. So I'm going to zero it out on this side, and I'm going to put it over here. But at the same time, I really want to move that to the other side. So I'm going to add a 24 here, and add a 24 over here. I'm going to kind of put two steps together. So what we pick up on is this negative 24 and 24 will zero out. These will come together as a negative 8x and a negative 12y. So those really don't come together, so I just put those down. A negative 12y and a negative x, so a negative x and a negative 12y. We usually like to put the x first. On the other side, the 12y and the negative 12y will zero out, and I have this 24 here. The other thing we like to do is, I really just like to have the coefficient of x be a positive. So I'm going to change this sign. But if I change this sign, all the signs have to change. So I'm going to write this as 8x plus 12y is equal to then 24. So that's now what we call standard form. Let's look at this second equation. I have 1 plus 5/9 y equals negative 7/18 x. I'm recognizing that this has fractions. One thing we learned, we kind of played with those complex fractions earlier. We are able to kind of manipulate fractions a little bit by finding what we call a common denominator. So if you look at the 9 and the 18, so the least common denominator between a 9 and an 18, well, the next multiple of 9 is 18. So I'll pick up 18 as a common multiple. So what I'm going to do is use that 18 to get rid of fractions. So I'm going to multiply this side by 18. And I'm also going to multiply this side by an 18 to keep it equivalent. So I'm now going to distribute through the parentheses. 18 times 1 is 18. But the reason I put that 18 there is because 9 will go in 18. So notice how 9 will go in 18 twice, and 2 times 5 would be 10. That's going to change that into a 10y. So I'm going to go ahead and divide first. 9 goes 18 twice. 2 times 5 is 10, so that gives me a 10y. Here, since the 18 goes in 18, I'm going to go ahead and just do that. 18 goes 18 one time. That's going to give me a negative 7x. So from here, what I'm seeing is this has got to go over here, and this has got to go over there. What I'm kind of learning is if I move to their side, all I'm really doing is changing the sign. So what I'm going to do is when this comes over here, I'm just going to write that as a 7x plus a 10y. And when this goes to the other side, it's just going to change sign as a negative 18. So I can kind of do it in that fashion. Okay. So I've got them both in standard form. That took some work. So now I have 8x plus 12y equals 24. And I have 7x plus 10y is equal to negative 18. Okay? Now, these look a little bit more familiar. I could graph these by trying to find the x and y intercepts, but I'm already picking up on some hard math here with the x-intercept here. It looks like it's going to be a weird-looking fraction. So graphing is really not going to look very good at all. So we're going to approach this using what we call the elimination method. So we put them in standard form, we want to make the coefficients the same number but opposite in sign. So what I'm looking at is these coefficients of the x's and the coefficients of y's. I'm trying to find which one of those to eliminate. Well, not seeing anything great with either one. I'm just going to go ahead and go with these x's. So the 8 and the 7. What I'm picking up on is 8 times 7 is probably going to be my least common denominator, or in this case, least common multiple. So what I want to do is use a 56 as my number. So what I have to ask myself, what am I going to multiply that 8 by to get this 56? And what I'm picking up on is, I would have to multiply that 8 by that 7. So my first move, I'm going to have this 8x plus 12y is equal to 24. And I'm going to multiply each side by a 7. So I'm going to have now 8 times 7 is going to be 56, 56x. 7 times 12 is going to be 84y. 24 times 7, I really don't know. Looks like 168. Okay. Now I'm going to this other equation. I have 7x plus 10y is equal to negative 18. And what I want to do is I want to make it a 56 as well, but notice that I want it to also be opposite in sign. So what I want to do is multiply by then a negative 8. So I'm going to have negative 8 times 7 is going to give me my negative 56x. Negative 8 times 10 is going to give me my negative 80y. Negative 18 times 8, I'm not really sure. So it's going to be 144. And we know a negative times negative is going to be a positive. So I'm going to be a positive 144. So what I'm going to do now is bring these together. So I'm going to have 56x plus 84y equals 168. And I'm going to have this negative 56x minus 80y, I'm sorry, yeah, 80y, is equal to 144. So I made my coefficients the same number but opposite in sign. So I chose the x's in that case. My next move is now to add the equations together to eliminate a variable. So as we kind of see, these x's are going to eliminate. 84 and a negative 80 is going to give me a 4y. 168 and 144. It's like what? 12, 11, 312? I'm seeing a 312. Now, to get x or get y by itself, I divide each side by 4. So 4 going into 312. Okay, you can use a calculator for that. Looks like a 7 goes there, and then an 8. So looks like we get a 78. So y is going to equal then a 78. So you can kind of see why this strategy becomes pretty important, because graphing that, you can really see that that's not going to be very good at all. So I found one of the variables. Now I got to solve for the remaining variable. So, or I'm sorry, substitute in, we're at the last step there, substitute to determine the value of the variable. So I'm going to go back to the original equations aren't much fun. I actually like when I clean those up and put them in standard form. So I'm going to use one of these equations. It doesn't matter which equation you use, they're all good. But I want to choose one that I think I can do the math without a whole lot of work. I think this one or this one. Oh, let's do the second one. So I'm going to have then 7x plus 10y is equal to negative 18. And I'm going to replace the y with that 78. So I'm going to have 7x plus 10 times 78. That's equal to a negative 18. So I'm going to have 7x equals 780. I'm sorry, 7x plus 780 equals negative 18. And then I have to solve for x. So I got to subtract 780 on both sides. So I'm going to have 7x equals a negative 798. So I've got that math. Yeah. And then I have to get x by itself. Divide each side by 7. X equals then, looks like I have to do 7 into 798. Again, feel free to use your calculator there. I just can't seem to find mine right now. So 7 goes into 7 one time. 7 goes into 19 twice. Looks like I can get my 58 there. And 7 goes to 58 like 8 times. So I'm going to get 128 and 2 sevenths. So 128 and 2 sevenths. So getting some crazy numbers here. We haven't had a hard number all this time, and all of a sudden we get these. That happens. So now I got to figure out where to write my solution at. Well, I'm going to go up here by this. I'm going to clean me out a spot here. Get rid of some of my scratch work. So we had x is going to be 128 and 2 sevenths, while y was 78. So we get that as an answer. So there we have it. That's our solution to this system of equations. You can kind of see when you get some crazy looking numbers, you're going to get probably some difficult answers, but the math can be done. You just have to be patient with it. We'll do a few more of these, so stay tuned.